Alrighty, here we go. Let's get week 2 notes done. So just as an aside, before you get started, when you log into your iLearn, right, you go to look at it. I want to look at it as a student. And when we do it, that's weird. Anyways, because I have to go to the right class. If I want to view this as a student. So if you go into Super Web Design, week 2 notes, I went and had added a template that you can use if you want. So if you click on this, it'll open up a Word document, in which case these are all the topics that we're going to cover today for this week's notes. So we're going to cover hardware, software, what access is, what a client is, hypertext transfer protocol, domain name server, IP addresses, what a server is, RGB, hexadecimal, what a cache, CMS, domains, what are domains, what is hosting, what are dev fees. So those are the topics we're going to cover. But all you have to do is make a copy of this document and then just go ahead and put in whatever notes you like, whatever you think are appropriate for each of these sections that we're going to talk about. And then just go ahead and turn that in. Again, I'll put the due date for this one on Friday again. So hopefully you should be able to get it done before then. If you haven't turned in last week's notes, they are now late, of course, and you will lose some points. So keep that in mind. But so to turn in, you haven't lost all points if you haven't turned it in yet. So still, if you haven't turned it in yet, do it quickly. All right, so let's take a look at what we're going to cover today. Oh, not that one. I'll open up the notes, the lecture. Let me just full screen here. Can I do view? There we go. So a little review before we get started on the new stuff. Let's take a look at what we've learned so far. Just a little bit. Alright, so who remembers what any of these things are? Alright, you've got this HTTP thing over here, right? You've got this thing over here, and the whole thing, right? This is our domain name, right? This is our hypertext transfer protocol, and the whole thing is a URL. So the domain name is Google, HTTP, Hypertext Transfer Protocol, and URL is their Uniform Resource Locator. We talked about what makes a good website. So design, functionality, UI, user interface, and usability, UX, or user experience. So, I don't know if you can hear the people talking in the hallway out in the background. But anyways, this is one of the downsides of doing my stuff, recording stuff on at school instead of in my apartment. But anyways, all right, so we've all been on the internet, but what do we actually need to access it? How do we actually get on the internet? Good question, right? Dave, that's why I asked it. All right, so there are 3 things that we need in order to access the internet. We need hardware, software, and access. Those are the 3 components of being able to use the internet. Alright. Hardware. You're using hardware right now, so a physical device with some kind of screen on it. Your biggest challenge, of course, is delivering the same content and experience on a different size screen. So some people are going to be browsing the web on their phones. Some people are going to be browsing the web on a laptop or an iPad or a tablet or a big desktop with, with 4 screens on it or whatever it is. So you have to make your website usable for all those different devices. So different software. There are different pieces of software, types of software, with all the same type, essentially, but the same different brands of software, I guess we could say it that way, that you can use to access the internet. And usually these are browsers, all right? So we've got Internet Explorer, Google Chrome, Opera. There's Tor browser. I don't know if that one really gets used all that much anymore. Don't try to use that at school. It's all different kinds of browsers that you can use, and they're always coming out with more like little niche browsers that you can use to have my different things as far as privacy goes or whatever it is. Right? But again, the most common one, of course, is Google Chrome. Some of the biggest challenges of designing a website when you're talking about software is say like your grandma still has her old gateway computer from the early 2000s, and and it's still running Internet Explorer, some old version. They can't run the latest version of HTML5. Then how can you make a website at least? It's not gonna have all the features that all the cool features that you designed, but at least make it usable for for Nana or Oma or Grandma or whatever you want to call her, Abuela, whatever you like. How can you make your website usable for her, right? And make it usable for people who have bought the latest Origin PC or something like that, right? So this is known as cross-browser compatibility. How can you make your website have the same general experience on like Safari as it does on Google Chrome? And the third component is access. How do we actually get on the internet? How do we access the internet? Right? There's Wi-Fi, which doesn't really stand for anything. It just sounds cool. Right? That's a made-up marketing term, Wi-Fi. 3G, 4G, or 5G nowadays. Hopefully, if you have a cutting-edge device, you're using 5G maybe. Or people still use dial-up. You're out in the country. You might still be using dial-up in order to access the internet, believe it or not. Some of the biggest challenges, of course, are accessibility. Maybe you're in a dead zone, or you're out in the boonies somewhere, and you just don't really have very steady access to the internet. Speed, if you're using dial-up as opposed to using like Ethernet or 5G or something like that, then it's going to be much slower. So you have to think about some users might be have a hard time downloading like large files or like a graphics heavy website, and will really slow things down and make their website not usable for them. Okay, now we have to talk about how do we view the web? How do web pages actually get displayed on our screen? Let's think about that. How do they actually get onto your screen from where they are stored? So the first thing we have is our client, all right? So Chrome, Firefox, Safari. This is not actually what you're looking at on the YouTube channel. There's not. The thing that I'm using is a PDF, so it's not using a browser. But I could use it on, I could do this PDF on Google Chrome or something instead. But you could use like Firefox, Safari, or there's other browsers out there as well that we've talked about. Now we've mentioned this before. We haven't gone into great detail about what a hypertext transfer protocol is. But essentially, it's a way to connect your browser will use hypertext transfer protocol to connect different things on the internet, all right? So it says, get ready to retrieve and receive information for us. Then we have our domain name server, our domain name. So after the http://www, then we type in the domain name, like google.com or archimedesacademy.org or whatever it is. Right? So the DNS maps the domain name, whatever we type, google.com, into an IP address. We'll get into that in a second. So again, it's like a phone book we talked about says when you look up someone's name, all right, like you look up, Dave McClain in the phone book. Not that people use the phone books anymore. if you were to look up Dave McClain in the phone book, it will tell you whatever my phone number is. So now we don't have to memorize a bunch of IP addresses because we can just remember. It's much easier again as a human being to remember google.com than it is to remember 192.58.36 whatever. All right, we don't have to worry about that. The DNS, the domain name server, manages all that for us. All right, and we just talked about this, but the IP address, Internet Protocol address, right? So it takes your domain name, the domain name server maps it to an IP address, which is just a bunch of series of numbers, separated by periods, and it requests information from wherever that information is stored on a server somewhere. I need the servers in a second. Server. All right. So the server is what the host is what hosts. I think we forgot the S. All the content of the site. So your images, your movies, your HTML, your CSS, your jQuery, your JavaScript, all those cool things. So it uses the IP address that the server retrieves and sends the appropriate web resources for that site. So your browser, using hypertext transfer protocol, contacts the domain name server, and then that figures out, all right, I typed in google.com, that means I need to look up this IP address, right, in which case, and that connects you to a server. This gets complicated, right? And that server has all the information, it has, the images for the Google, whatever the Google, doodle for that day is, and, all the HTML and all that kind of stuff. And then it transfers all that back to you, to your browser, and then your browser turns that into information that you can see with your eyes. So here we go. Here's an image of it. And so here we are. We're at this point right here. We're using our browser, and then the hypertext transfer protocol is, this person just typed in some stuff. All right. Hopefully it makes sense. And from there, the DNS, the domain name server says, here's the domain name they typed in. And from here it goes, what's the IP address for that domain name? From there, go over here to the server, and the server says, this person wants, to watch this new video on YouTube or whatever it is. And from there, it says, where can I find it? And it finds our default document. And then from here it says, here's some HTML on this document, here's some CSS on. Usually the default document is like your index.html or whatever your home page is. Some JavaScript, and it goes all the way back to the user. Now I can look at this cool website. So this is how information goes from. This is how whenever you type. So if I go to let's open up google.com and GPP. All that happened in that brief, microsecond from when I typed in google.com. All that happened. So it went all the way to the Google domain name server and brought in that stuff right back onto your screen. So that whole process that we just talked about. So if I go to, cnet.com. That whole process that we just talked about just happened. It seems like a lot, and it is a lot, really, but internet nowadays is at the point where this can all happen, in an instant. Whereas when the internet first started, using dial-up and everything like that, everything slowly went down the screen, and then to listen to to download a song might take you like 15 minutes, that kind of stuff, depending on how fast your internet was. But luckily, we've moved on from there. All right, so next we're going to talk about color. So there are multiple ways that we can say what color is, or how to translate the colors that we see with our eyes. How does the computer understand what color is? A computer doesn't actually see colors, but the computer does understand the numbers. So when we talk about printing, like you want to print a book or something like that, right? We're talking about CMYK colors. So cyan, magenta, yellow, and black. A mix of all those different colors will basically give you any kind of color that you can think of. So when you look at, I don't know, like this Raspberry Pi box over here, okay? This got printed out with the CMYK color process, or values. We're not too worried about that. But we, at the computer, when we're looking at the screen, we can see our screen here, we've got black and white. Those are really the only two colors that we're seeing. It gets translated, instead of CMYK, cyan, magenta, yellow, and black, it gets translated as RGB, red, green, and blue. Those are the three colors. We can mix those colors in different ratios, and we get basically all the colors of the rainbow. And then some. Our computer monitors offer a larger spectrum of colors available to us on the web than compared to print. That is true. So, like I said, on our screens can basically print out essentially any color that we can think of. And obviously, the more resolution they have and the more advanced our screens get, the more detailed our images can be. So, I don't know if sometimes if you look at something in a book and you see the exact same image like on your screen, the colors might be more vibrant on the screen. All right, so RGB again was red, green, blue. So red, green, blue. So any color basically can be represented by a mixture of different amounts of red, green, and blue. And it's done in bits. We haven't talked about bits yet, but a bit is just like a piece of information. So there are 8 bits to represent each color. So 2 to the 8 equals 256. So there's 256 options. When I say a bit, something is either on with a 0 or it's off. Or the other way around. Usually off is a 0 and on is a 1. So there's 256 different combinations you can come up with for each color. So there's 256 shades of values of red and green and blue. So starting up from 0 all the way up to 255. So counting the 0, that's 256 different options. This all makes a little bit more sense here in a second. So one way we can do this, the most common way to translate color into RGB for the computer is through hexadecimal. Now our standard decimal system that we use goes from 0 to 9, right? So hexadecimal goes from 0 to 9, and then A through F. So A is essentially 10, B is 11, and so on and so forth, all the way up to 15. F would be 15, right? So 16 digits, 0 through 15. That gives you the 256 options. So that's the 256 that we talked about, 2 to the 8. So, and there's 2 hexadecimal numbers for each color. So there's 2 hexadecimal numbers for red, right? 2 hexadecimal hex numbers. Let's go with hexadecimal. I'm not going to trip over saying it a bunch of times. 2 hex numbers for green and 2 hex numbers for blue. So if I was going to do red, which we're seeing right now, it would be FF0000. This is like bright red. This is red as red can be. And also you'll notice that we started off with a hashtag or a pound sign. So this would be all red, 255, 255, 0000 on the green and the blue. I'm doing blue. What do you think it would be? That's right. The 0000FF, because blue are the last two numbers. If I'm doing purple, it's probably going to be some mix of red and blue, right? So it could be like FF00FF, or something in between. Now gray is going to be 999999. Before I move on, I want to show you one thing. All right, let's look at. If you go to there's lots of different websites that will do this for you. Hex Color Picker, right? It'll basically transfer this right in Google. It'll translate any color you want into a hexadecimal number, right? So if I go all the way green, right? You can type it in, right? FF0000, right? It gives you red. If I type in, I don't know, 00FF00, it's going to give you green. If I type in FF, gives you white. What do you think happens if I type in 000000? It gives you black, right? Or if I type in, I don't know, FF00FF, gives you that purple color. Now again, there are different shades you can get. Like if I want to do like a darker purple, you can see BF00FF and so on. There's no green in this purple color. Let's do that 99. Let's do that 999999, right? Gives you that gray color. So there you go. Anyway, let's go back to our notes. Cache. I'm going to go with cache. So browsers save bits and pieces of every web page you visit. So next time you visit the page, it can be delivered to you quicker. But that is saved in your browser's cache. Websites that you visit often will be saved in your cache. And every so often your cache will be cleared out, or if you can do it on your own. If you haven't cleared out your cache in a long time, it might take up a decent amount of storage on your computer, in which case you might want to clear it out, especially if you're, say you're working on like an iPad or like some kind of tablet or a Chromebook or something like that. It doesn't have a lot of memory. You might want to clear out your cache every so often. Well, like I said, if you have a big computer or a computer with lots of storage, then it's not that big of a deal. Every once in a while, it might be okay to just restore your computer. CMS, right? Different systems will use something called a CMS, a content management system. So it allows users to make content for their web page through a UI user interface and with little to no coding, typically used for professional websites. So it separates the content makers from the coders. So, I don't know, I've heard of Squarespace or different things like that, or Wix pages, I think, is one. Those are different content management systems that you can use. So we're focusing on the coding part, all right? So there's someone who might be a content manager, like say you want to make your own blog, something like that, or you want to make a site to sell your custom-made, hammocks, whatever it is, right? You don't care about, customizing your own code. You want to just use whatever the content that, that Squarespace or whatever it gives you. You can modify a little bit. You don't have to know so much code in order to do that. So if you're a content manager, it's different than being someone who codes. I mean, you could be both, for sure. Say you're a coder and you just want to throw up a quick website. You don't want to deal with actually writing the code. It's like content management systems will do a good job for you. The downside to a CMS is the amount of customization that you can do. So your site might look a little bit cookie cutter compared to other websites. So, I mean, it's not a big deal depending on what it is that you're trying to accomplish. So WordPress is professionals will use WordPress a lot. So it's one of the most popular content management systems out there. So and it's got a big community and it's relatively easy to use. So it's good for personal and professional sites. How much does a site cost? Those are three main things that we have to worry about when it comes to how much a site costs: the domain, hosting, and designer and developer fees. So domains, catchy names cost more money. So coming up with a website called, Mr. Dave at mrdave.archimedes fancypants .net or .teach or whatever it is, right? That's going to be a lot less expensive than I just type in, than like dave.com or something like that. That's going to be the more easy to remember. Think of it this way: the more easy to remember, the more simple the domain name is, the more it's going to cost you, generally speaking. So there's also domain types, .coms, because usually when the internet first started, basically everything was .com. So by default, when people type in a website, they're going to think of it as a .com website, even though it might be .net or like archimedesacademy.org, right? You have to, some students will just reflexively just type in archimedesacademy.com, and that takes you to something different. I don't know if it takes you to anything at all. But there are ways to get things like redirected or whatever like that. But anyways, that's neither here nor there. What I'm mainly worried about is the domain type, right? Will reflect a change in how much the domain costs when you're going to make your own website. There are also .ca, which is Canada, or .cn, which is China. Different country domains might be added on at the end over there to whatever things. Or I don't know if you see like .io or .tk is that one you'll see sometimes. Those are different country names, all right, or abbreviations. And there's also different protected names like .edu or .gov. In order to have like a .gov website, it has to be officially like a government website, or .edu has to be like an actual school. You can't just make up a .edu domain name. You have to actually like prove that you're a school. So how much the price is set by the owner of the domain. So if GoDaddy owns the domain or whoever it is, they determine the price. Now you can buy a domain. There's like domain name, they call them squatters. They will buy domain names that they think that other people will want eventually, and they'll just buy it even though they don't have any intention to use it for their own website. They might say they do because they, in certain cases, they might have to prove that they have some kind of intention of making like a website out of it. But a lot of times they'll buy it and not have any real intention of doing anything with it, in the hopes that someone comes along and says, "Oh, I really wanted, MrDave.com." But someone owns it and doesn't not only do anything with it, so they might try to sell it to you for some exorbitant amount of money, depending on how popular the name is. You can get your own domain name at Namespace, nc.me, so you can get free .me domain names for a year to students. You can try that out if you like. And I think there's a way with GitHub in order to transfer your stuff into a .me or a .tk domain name. Or if, like, say, if you want to buy your own domain name, you can. Some will cost a decent amount of money, some are relatively cheap, and usually you pay depending on where you're buying the domain name from. It might cost you, like a few dollars, or it might cost you, thousands and thousands of dollars. So the next thing we have to worry about as far as how much a website costs, right, is hosting. So if someone's accessing like videos and images and a bunch of text and all that kind of stuff, that has to be stored somewhere. It's not stored on your computer. It's stored like on a server somewhere that we talked about. So, and they will charge you different amounts of money depending on whoever the host is for you, and how much traffic or how much internet stuff you have going through your how much traffic you get. It's basically how many people are using your website and what kind of stuff are they downloading or are they transferring. So if you have like a bunch of videos that you're watching, that's going to take up a lot of data, and that might cost you more money in the long run. So there, when you're talking about hosting fees, you're talking about basically how many sites you host. Might just be one, it might be like a few, or it might be dozens. How much traffic you get, and how much server space you bought. So you might only have a few gigabytes, or you might have terabytes, in which case it's going to cost you a lot more. A terabyte is 1,000 gigabytes. And then, if you're not designing your own website, you have to think about your dev/design fees. If you're talking about a freelancer, like if say you're just doing it on your own, right? You don't work for a big company, you are a freelancer. So freelancers generally cost more, but they don't have, the reason why is they have to pay for all their like their health benefits and all that kind of stuff, right? The upside to hiring a freelancer is that you get more personalized attention. So, the purpose of every website ever is to, I'll pause here for a second. What do you think the purpose of every website ever is to? Just think in your head while you watch this YouTube video. What's the purpose of every website? It is to serve and deliver information. Whether it's Wikipedia, whether it's YouTube, whether it's SI.com or CNET or ArchimedesAcademy.org, it gives you some kind of information. And the language that we do this with is HTML. And the most current version of HTML is HTML5, which stands for Hypertext Markup Language. And gives us the structure for our websites and its content. So I think of HTML5, when you think of like a website as like a body, think of HTML as the bones, where it kind of tells like where everything is. Now, in the early days of the internet, all we had were the bones. There wasn't CSS and all that kind of stuff, JavaScript, jQuery. That stuff didn't exist. Well, it was in its infancy, and it wasn't really part of the internet structure. So, HTML, the bones of your website. Now, we're going to get into this later, right? But what we're going to do is, once you've made your first Hello website, the Hello World website, we're going to go and make it a little bit more detail as far as add a few other things. All right. So for your next website, this is what we're going to make. We'll get into this later, not today, right? Or whenever it is you're viewing this website, this YouTube video. But let's take a look at what it is. We've got our doc type tag. We've seen this before. We've got our HTML tags. Opening and closing. We've got our head. We haven't really dealt with the head too much. Head tags store. This is where you're gonna put stuff basically that doesn't show up on the actual as content on your web page. It's more stuff that shows up in the tab or that sets things up. It's metadata kind of stuff. I don't know if you know what metadata is, but it's like data that's like about the whole website rather than the actual information on it. Think of it that way. Then we've got our body, just like in the regular body, like your head goes up top and your body is below it. So head, stuff inside your head, right? And then we've got our body, which is all the stuff that we're interested in, right? So we've got our headlines over here. We've got an H1. We've got a paragraph. We've got 3 links over here. We haven't gone into this yet. These are hyperlinks. These are A tags, hyperlinks. We also have this div tags, opening and closing div tags. This is like a division of your website. You can divide your website up into different spots using div tags. So we'll be doing this later, but I just wanted to show you the actual HTML. Alright, and just briefly I want to mention CSS, which stands for Cascading Style Sheets. And so we talked about HTML is like the bones. The CSS is essentially the skin that makes everything look pretty, right? So this is what CSS looks like. Again, we'll get into this eventually, not at this second. So we've got div. We're aligning it in a certain way. It should be in the center, right? We can see our H1. We can change the font, what the image is, right? What the paragraph is. We can change the width of the paragraph. We can give it a margin. Right? Our A tags. We can make them look fancy. All this kind of stuff. Again, I'm not worried about all this stuff is right now. When I give the lesson on this stuff later on, we'll go into more depth and more detail what all these things are. But this is like how you're going to make your website pretty. All right. So what this looks like is going to be entirely different once you would connect it to the CSS, and we'll get into how to do all that later. All right. So that's what I have for today for the notes. I know. How long is this video? 36 minutes. So, again, try to get this into me by Friday, and we'll take it from there. Okay? I will see you guys at 10:16 in about an hour. Adios, muchachos y muchachas.